Okay, natural logs. Maybe you have seen the LN button on your calculator, but that represents natural log or natural logarithm. The way natural logarithms are described in your textbook, it can be kind of confusing. What it says is that it's the inverse of an exponential function, and since y equals e to the power of x is an example of an exponential function, it's the inverse of that, is basically what it's saying. But that's kind of hard to grasp. So, let's bring this up. So further explained, here's like a fresh, different explanation. The natural log gives you the time needed to reach a certain level of growth. So the logarithm is all about time, and exponents is about growth. So we've learned exponents. So if we have like y equals e to the power of x, we're trying to determine the amount of growth after time x. So like, let's say we're given 3 years. We would just do e to the third power and be given that answer. If we were given 8 years, we would do e to the 8th power, and that would tell us the amount of growth we had. Now logarithms is about time. So we're trying to find the time needed to grow to x. So suppose you have an investment in gummy bears, this says who doesn't, with an interest rate of 100% per year growing continuously. So if we want 10 times growth, assuming continuous compounding, we'd wait only ln 10 or 2.302 years, or vice versa. When we did e to the power of x, like if we typed in e to the 2.302 power, we would get 10, the 10 times growth. So e to the power of x lets us plug in time and get growth, where ln of x lets us plug in growth and get the time that it takes. So for example, e to the third power is 20.08. After 3 units of time, we end up with 20.08 times what we started with. ln 20.08 is about 3. If we want growth of 20.08, we wait 3 units of time, again, assuming 100% continuous growth rate. So the last part says, with me, the natural log gives us the time needed to hit our desired growth, where the exponential, we're given the time and it tells us what our growth is. So let's practice using this. The base of a logarithm, when not written, is always 10. Well, the base of a natural logarithm, the ln, is always e, because again, it's the inverse of the y equals e to the power of x. So to solve each of these equations, when we're given the natural log, to solve the equation, we would convert it to exponential form. But again, the difference is the base isn't 10 here, it's e. So to convert to exponential form, now it's still the same. It's ln by equals x, and b to the power of x equals y. So nothing's changed in the type of forms. B is still in the same spot, y is still in the same spot, x is still in the same spot. So here, it's going to be e to the 4th power. There's our b, there's our x, and our y is 3x plus 5 squared. Okay, so to solve this, we would take e to the 4th power, and then we have to do 3x plus 5 squared. Actually, no, we don't have to do that. And I'll show you why. So e to the 4th power is about 54.5982. We'll round to 4 decimal places we have so far, so why not, or why stop? And then 3x plus 5 squared. Remember, when we're squaring something, we can square root it to find the answer. So our first step is convert to, if you're a step person, your first step is write in exponential form. And then the second step is solve for x. So this could be umpteen different ways you have to go about solving for x. In this case, to solve for x, we have to first square root both sides. So the square root of 54.5982 is about 7.3 2.389, and that equals 3x plus 5. So then we would subtract 5 from both sides, and again, I'm still solving for x. And here it's 2.389 equals 3x. So here again, still solving for x, we would divide everything by 3. So 2.389 divided by 3 is 0.7963 is our x. And so then we would follow those same steps here. Why don't you pause the video and try this one and write it down in your notebook, and then check your answer in the end, and if you don't get it right, I will address it tomorrow. But your answer should be 5.463. And you might have it rounded a little bit differently here, depending on how you type it in your calculator. I didn't round anything until the last step, so it might vary just a little bit. But you should get x equals 5.463. And again, if you missed that, bring that in tomorrow, and we'll discuss it. And then the last thing we'll have to do is, given exponential form, notice the base is always e for these problems, we are going to have to solve these equations as well. So just like we had to when we solved the exponential equations with the logarithms, anytime you have an exponential equation, to solve it, we always have to first get it in exponential equation form. So get it in the y equals b to the power of x form. That's your first step. So here in this case, we'll have to subtract the 2.5 first. I know I'm going to have to move that down. Subtract 2.5, so we'll have 7e to the 2x power equals 17.5. Then you might say, all right, well that's in y equals b to the x form, but actually it's not, because it's a times b to the power of x here. So we have to get rid of this 7 out in front, and 17.5 divided by 7 is 2.5. So we have e to the 2 times x power equals 2.5. So now it's in the b to the power of x equals y. So now we can solve, and because our base is e, we don't log both sides, we take the natural log of both sides. So second step is take ln of both sides. So we do that, and we'll have 2x ln of e equals ln of 2.5. Okay, and then it's just going about and solving for x from here. So natural log of 2.5 divided by natural log of e. But I think natural log of e should be 1 anyway. Because when we do natural log of e, oops. Natural log of e is 1, because thinking e to what power gives us e? Well, it's e to the first power. So when we natural log e, that just goes away. It's 1. So we have 2x equals the natural log of 2.5, and then you can divide both sides by 2. So the natural log of 2.5 divided by 2 is, whoops, 4x equals 0.458, or 0.4580. Nope, I lied, 0.4581, goodness. So x is 0.4581. And so obviously the third step is solve for x. So let's look at D here. Same scenario. I want you to go ahead and try it first, following those steps, and I will do it here quick and get my answer. And I got x equals negative 0.3581 debatable to put a 2 there, but I'll just keep it like that. So if I raise e to that power plus 1, oh. Okay, so if I do e to the power, I'm checking my answer, of negative 0.3581 plus 1, and then plus 7.2, I get 9.100087618. So pretty darn close to 9.1 considering I rounded here. So that does check out to be the correct answer. So you can always check into that. And then lastly here, for letter E, an investment of $100 is now valued at $149.18. The interest rate is 8% compounding continuously. About how long has the money been invested? So given this compounding continuously, what should pop into our head is this formula. A equals PE to the RT power. Perfect. Our principal is what we started with, so it's 100, but it's now valued at $149.18. So that's our A. After a certain amount of time, we have $149.18. We started with 100. E is still E. The rate is 0.08, and the time is what we need to find because it says how long has the money been invested. Okay, so what we need to do here is solve for T. So get rid of our principal, our A essentially, because it's y equals A times b to the power of x. Get rid of our P here, which is our A, so divide by 100. So 149.18 divided by 100 is, duh, I should have known this off the top of my head, 1.4918 equals e to the 0.08 t power. Okay, and we should say, all right, we're in our y equals b to the power of x form. So let's take the natural log of both sides. We'll have natural log of 1.4918, and that's going to equal 0.08 t, because natural log of b is just 1. And then to solve for t, we would divide by 0.08. So natural log of 1.4918 divided by 0.08 is rounded. It's 4.99979, so I'm going to say t is about 5 years. So it'll take 5 years to earn the $49.18.